Hi, this is lesson 7, which I'm sure will shock you to find out is Newton's third law. Just take a moment, pause the video. In your own words, what is Newton's third law? The phrasing I like is, for every action there is an equal and opposite reaction. So whenever there's a force, there's an equal and opposite force. So forces always come in pairs. That doesn't mean that forces are always balanced, because if forces were always balanced, nothing would ever accelerate. What it means is that whenever you've got a force one way, somewhere else in the universe, there must be an equal and opposite force of the same magnitude. So that's what it means. I'd like you now to look at this diagram of a bullet. This was something I actually took from a physics teaching resource. I won't tell you where I got it from. 2 of these 4 forces are not real. Which is interesting, because it looks as though we've got equal and opposite forces on the bullet, all nice there, obeying Newton's third law, but it isn't. 2 of them are wrong. Pause the video, have a good old think, which 2 of these 4 forces are wrong? Did you get it? The answer is, well, if you've been watching my previous videos, upthrust. What would upthrust be on the bullet? What would be the force pushing the bullet up here? It's just a bullet in flight. It's just flying through the air. There's nothing pushing it up. Bullets don't just fly further and further upwards into the air. So we know that's not one. The other one is thrust. Once it has left the barrel of the gun, and the bullet is just in flight, there's nothing pushing it further forward. Now here's a much harder question. These 2 forces are real. The bullet does experience air resistance, and the weight of the bullet is pulling it down. What are the equal and opposite forces to those 2? To answer this, we're going to have to think a little bit about field theory. Field theory says there are only 4 forces in the universe: gravity, electromagnetism, strong nuclear force, and weak nuclear force. And all the other forces we talk about, thrust and buoyancy and so on and so forth, are actually just expressions of each of those forces. Weight is obvious, that is gravity. It's gravity pulling it down, which means the bullet's gravitational field must be overlapping with another gravitational field. If this bullet is on Earth, then it is the gravitational field of the Earth itself. So as the Earth pulls the bullet towards it, the bullet actually pulls the Earth towards it as well. Those 2 fields are overlapping and they're both exerting a force on each other. Obviously the Earth isn't going to move very much towards the bullet, but it's there, it's real, it's just very, very small. If we look at the equation for gravitational force, we can see that the force is equal to a constant multiplied by the 2 masses divided by the distance between them squared. So the force on mass 1 is going to equal the force on mass 2. It's going to be the same regardless of which of the 2 masses you're looking at. The only reason the bullet seems to experience a greater movement is because its mass is so much less, F equals ma, therefore for the same force the acceleration will be far, far higher. The Earth will accelerate towards the bullet, but only a very small amount. So now we've dealt with the weight, take a moment. Which field does air resistance come from, and what is the equal and opposite force? The answer is electromagnetic. Here's a question for you. Why can't I push my finger through my hand? What's stopping that from happening? Well, what's on the very outside of my finger? If you look closely enough, it's going to be atoms surrounded by electrons. Exactly the same on the outside of my hand. So the electrons on my finger and the electrons on my hand push against each other. If you think about it really carefully, you never actually touch your hand. They never actually get close enough. Just the electromagnetic fields interact and push against each other. Exactly the same thing is happening here. The electrons on the outside of the air molecules are interacting with the electrons on the outside of the bullet, and they're pushing against each other, equal and opposite force. So as the air molecules push against the bullet pushes against the air molecules, and that is the equal and opposite force. So, for the rest of your life, whenever you're considering Newton's third law, do not draw arrows opposite each other on the object, but instead turn your brain on, think which field is happening here, think about which two things must be interacting with the same field, and your equal and opposite forces will magically appear. Questions underneath. See you tomorrow.